Hi, I'm Bob. Welcome back to our solutions to the exercises from the textbook Microeconomics, Theory and Applications with Calculus, the 5th edition. We are now in the section on two-part pricing. Let's solve exercise 5.1. Using math, show why two-part pricing causes consumers who purchase few units to pay more per unit than customers who buy more units. Suppose the firm charges a lump sum access fee, L, and a per unit price P. Consumers pay L plus P times Q to purchase Q units of products. The effective per unit price is P plus L over Q. As Q increases, the effective per unit price decreases. Let's find answers to exercise 5.2. The park charges an access fee to enter its crystal pool. It also charges P per trip down the pool's water slides. Suppose that 400 teenagers visit the park, each of whom has a demand function of Q1 equals 5 minus P. In addition, 400 seniors visit, each of whom has a demand function of Q2 equals 4 minus P. The park's objective is to set L and P so as to maximize its profit, given that it has no cost and must charge both groups the same prices. What are the optimal L and P? The monopoly charges each consumer the same lump sum access fee and the same per unit price. We can draw a graph to help solve the problem. Suppose the monopoly charges an access fee L so that both types of consumers purchase. The access fee L equals the potential consumer surplus for the seniors. We write the profit pi. Using the demand functions, we can write pi in terms of the per unit price P. Setting the derivative of pi with respect to P equal to 0, we obtain the optimal per unit price of 0.5. We then can calculate the access fee 6.125. The monopoly's profit is 6,500. We then consider the other case when the monopoly charges an access fee equal to the potential consumer surplus of teenagers, so that only teenagers purchase. It charges a price equal to 0 and an access fee of the teenagers' consumer surplus, 12.5. But in this case, the firm's profit is 5,000, which is lower than the first case. Thus, the monopoly's profit-maximizing choice using two-part pricing is to charge the access fee equal to the seniors' consumer surplus, 6.125, and sell to both seniors and teenagers at the price of 0.5. Let's do exercise 5.3. Joe has just moved to a small town with only one golf course. His inverse demand function is as follows, where Q is the number of rounds of golf that he plays per year. The manager of the club negotiates separately with each person who joins the club and can therefore charge individual prices. This manager has a good idea of what Joe's demand curve is and offers Joe a special deal, where Joe pays an annual membership fee and can play as many rounds as he wants at $20, which is the marginal cost his run imposes on the club. What membership fee would maximize profit for the club? The manager could have charged Joe a single price per run. How much extra profit does the club earn by using two-part pricing? As the graph shows, if the club uses two-part pricing, it charges a lump sum access fee equal to the consumer surplus, $2,500, and a per unit price of $20. The monopoly's profit is the access fee it collects, $2,500. The consumer will buy 50. By contrast, if the club uses single pricing, it sets marginal revenue equal to marginal cost at the optimal quantity. The monopoly price is $70. The monopoly profit is $1,250. Thus, the club earns $1,250 more profit by using two-part pricing. The consumer earns zero consumer surplus at two-part pricing, but plays more rounds of golf compared to the single pricing case. Let's address exercise 5.4. Joe, in question 5.3, marries Suzanne, who is also an enthusiastic golfer. Suzanne wants to join the club. The manager believes that Suzanne's inverse demand curve is P equals 100 minus 2 times Q. The manager has a policy of offering each member of a married couple the same two-part prices. So he offers them both a new deal. What two-part pricing deal maximizes the club's profit? Will this new price have a higher or lower access fee and per unit price than in Joe's original deal? How much more would the club make if it charges Suzanne and Joe separate prices? If the monopoly charges an access fee L so that both Joe and Suzanne come to play golf, then the access fee must be Suzanne's potential consumer surplus, as shown in the graph. We can write the monopoly's profit function. It collects access fee L from Joe and Suzanne, so it collects L twice. In addition, it charges Joe a per unit price of P for Q1 units that Joe purchases. The profit from that part is P minus 20 times Q1. Similarly, it collects profit from Suzanne in the amount of P minus 20 times Q2. Using Joe and Suzanne's inverse demand functions, we can write the firm's profit in terms of price P. The first order condition leads to the optimal price of $30. Then we can solve for the quantities Joe and Suzanne purchase and the access fee L. The access fee is $1,225. Finally, we can calculate the profit the club earns. It is $3,250. Compared to Joe's original deal, the new pricing will have a lower access fee, but a higher per unit price. We can verify that if the club charges a higher access fee so that only Joe comes, then the club's profit decreases. You may wonder why the club did not lower the per unit price to its marginal cost. That is because the loss in producer surplus from a lower per unit price more than offsets the gain from the access fee. If the club can charge Joe and Suzanne separate prices and access fees, it will charge Joe an access fee of $2,500 and a per unit price of $20. It will charge Suzanne an access fee of $1,600 and a per unit price of $20. In this way, the monopoly captures all consumer surplus and maximizes its profit. It is $4,100. It makes $850 more profit than charging Joe and Suzanne the same access fee and the same per unit price. Let's solve exercise 5.5. As described in the application Pricing iTunes. The researchers estimated that if iTunes used two-part pricing, charging an annual access fee and a low price per song, it would raise its profit by about 30% relative to what it would earn using uniform pricing. Assume that iTunes uses two-part pricing and assume that the marginal cost of an additional download is zero. How should iTunes set its profit maximizing price per song if all consumers are identical? Illustrate profit maximizing two-part pricing in a diagram for the identical consumer case. Explain why the actual profit maximizing price per song is positive. For identical consumers, the monopoly maximizes its profit by setting its price equal to its marginal cost and charging an access fee that captures the entire potential consumer surplus. So, iTunes should set its price per song to zero and charge an access fee equal to the blue triangle area. The actual profit maximizing price per song is positive because the consumers are not identical. They have different demand curves. From previous exercises, we know that if the monopoly has to charge the same access fee and the same per unit price to all consumers, the optimal per unit price should be above the firm's marginal cost, because the gain in producer surplus from a higher price more than offsets the loss in access fee. Let's go to exercise 5.6. Explain why charging a higher or lower price than P equals 10 reduces the monopoly's profit in figure 12.5. Show the monopoly's profit if P equals 20, and compare it for its profit if P equals 10. The monopoly engages in two-part pricing with identical consumers. All consumers have the same demand curve. Suppose the monopoly sets the per unit price equal to its marginal cost, $10, and charges the access fee equal to the entire potential consumer surplus. In that case, its profit will be $2,450. By contrast, if it sets a higher per unit price at $20, it earns a producer surplus of $600, but you can only charge an access fee of $1,800, which is the new potential consumer surplus. The firm's total profit will be $2,400. It's smaller than the profit in the case where the per unit price is set at the firm's marginal cost. It leads to the David laws of the C1 triangle area. Thank you so much for watching this video and solving the exercises with me. See you soon. Take care. Thank you for watching this video and subscribing to my YouTube channel. See you next time.